Alright, so today we're going to be finding out how to find the maximum area of a specific enclosure if given the amount of material that you are supposed to work with. So consider this. You have a barn and you want to put a fence next to the barn. So let's say this, you can label this barn, and we have 4 different pens or corrals. Each of these are going to be of side length B, and each of these long ones, or the length of each corral, is going to be A. Now, assuming that we have 10,000 feet of fencing, what are the dimensions of A and B to make a maximum area enclosure? So we're first going to figure out what are the equations we are going to need. Well, we know that the amount of fencing we're going to need is going to be 10,000 feet. So let me just highlight all of the fences of length B. So this will be B, 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 and B. So we have in total 8 segments that are going to be of length B. Then we have 1, 2, 3, 4 segments that are going to be of length A. Now we don't count this because this is part of the barn itself. So now what we're going to do is that we are going to create our first formula by adding the total length of all the B sides plus the total length of all the A sides to get us 10,000. So this is our first equation. Our second equation is to find the area of each corral, and this is going to be our function, which we're going to find the maximum of. So what we're going to do, we're going to write a function, or in this terms I'm going to write A as an area equals our A times B. We could do 4B times A, right? Because this is 4B and this is A to find the entire area of the entire segment. But it would make better sense to do AB because we just want to find the dimensions that maximize this area specifically. So the first thing we want to do is we want to get this function in terms of a singular variable. So what we're going to do here is I'm going to minimize these two equations as well. So I'm going to solve this so I can get one singular variable. So here I'm just going to do 8b equals 10,000 minus 4a. Then I'm going to divide each side by 8. 1250 minus 4 divided by 8, which is 1/2, a. Now that I know that b equals 1250 minus half of a, I can plug that into my area equation. So area equals a, which will be this a, times b, which I'm going to plug in this. So I'm going to put that in a different color. This would be 1250 minus half of a. And I left this place here because we can now write this as area in terms of a, right? Because we only have a singular variable. Now, we could distribute the a into here and get a quadratic in standard form, but instead we can leave it here. Why? Because if we were to draw a graph and we were asked for the zeros would be at 0, right? Because if we solve for the zeros, we get a 1250 minus 1/2 a equals 0. Either a equals 0 or 1250 minus 1/2 a equals 0. So a equals 0 or 1250 minus 1/2 a equals 0. And if we solve this out, we're going to get 2500 equals a. Now we know that our 2 points are going to be 0 and 2500. These are going to be our zeros. If we were to graph this, we know that a parabola will have its mirror points, or the points with the same y value, in this case 0, on opposite sides of its axis of symmetry, or a point in the middle. What this basically means is that this vertex is going to be directly in the middle of the zeros because this is just a regular parabola. So what's in the middle of 0 and 2,500? That's going to be 1250. No calculator needed. So what is this second value here? Well, we know that our x-axis is going to be representative of A, and our y-axis is going to be representative of area in terms of A. This is not the same as B. So now that we know that A is going to be 1,250, now we can solve for B. So from all of that, I figured out that A is equivalent to 1,250. So what is B? Well, if I plug this into my equation, HB plus 4 times 1,250 equals 10,000. I subtract 4 times 1250 is 5,000. 8b equals 5,000. I'm going to get b equal to 625. So the dimensions are going to be 1,250 feet by 625 feet per coral. This will give you the maximum area. To double check, we can do two things. One, does everything match up? We know that we have 4 A's, so we can do 1,250 times 4 to get us 5,000. And we have 8 B's. So 625, which is the side length of each B, times 8 total, give me 5,000. And 5,000 plus 5,000 will get us 10,000 total feet. Now, another way to double check is that whenever things tend to get squarer, they have an increase in volume. What that means is that, let's say I have something 8 by 2, right? That will give me a area of 16, okay? But the perimeter is 20. If I do something 5 by 5, the perimeter is still going to be 20, but since it's more square, it's going to, now the area is going to be 25. So whenever you get things to be more like a square shape, it'll have a greater area. The same concept applies here. You want to give an equal amount of fencing to the B lengths and the A lengths. So another way that you can solve this, or a way that you can double check this, is by first splitting 10,000 into two equal parts. You're going to give one to B and one to A. So that means you're giving 5,000 to B and 5,000 to A. What this does is that now you know that 5,000 has to be equally given among all 8 B segments. So you divide this by 8. And 5,000 has to be given along all 4 A segments. So divide this by 4. And you will get 625 for B and 1,250 for A. This is a very good way to double check and to make sure that your computation is accurate.